Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will take the first lesson in the trigonometry. It is called the main trigonometrical ratios of the acute angle. But at the first we need to remember the measure units of the angles. If we need to write the angle whose measure 22 degrees, 36 minutes and 48 seconds, it can be written as 22 degree, 36 minutes, and 48 seconds, where degree is denoted by small circle like that, and minutes is denoted by one dash, and second is denoted by double dash. And we need to remember that 1 degree is equivalent to 60 minutes, and 1 minute is equivalent to 60 seconds. But if we need to convert from degree into seconds, we can multiply 60 by 60. So 1 degree is equivalent to 3,600 seconds, because 1 degree equivalent to 60 minutes, and we can multiply by 60 to convert it into seconds. So it's going to be 3,600 seconds. If the ratio between the measures of two complementary angles is 7 to 8, find the degree measure of each of them. Suppose the first angle is called angle A and the second angle is called angle B, and the ratio between their measures is 7 to 8. It doesn't mean that the measure of the angle A equals 7 degree or measure of angle B equals 8 degree, because this is ratio. But we can break this ratio if we multiply each term of the ratio by a variable, say x. That means measure of angle A equals 7x, means 7 times x. And measure of angle B equals 8x, means 8 times x. We studied in grade 7 that the two angles are said to be complementary if their sum equals 90 degree. That means the measure of angle A plus the measure of angle B equals 90 degree, because they are complementary angles. That means 7x plus 8x equals 90 degree. Now we can add the like terms. 7x plus 8x equals 15x equals 90. This is an equation of first degree in one variable. We can divide each side of the equation by 15. So x is going to be 6. Now we can replace the letter x in the first angle by the number 6. So it's going to be 7 times 6 equals 42 degrees. So the measure of angle A, or the first angle, its measure is going to be 42 degree. And also we can replace the letter x by the number 6 in the second angle. So measure of angle B is going to be 8 times 6 equals 48 degree. So the first angle is going to be 42 degree and the second angle 48 degree. Now we will take the trigonometrical ratio of the acute angle. It is the ratio between two side length of the right angle triangle that contains this angle. If we need to find the trigonometrical ratios of the angle A in the right angle triangle ABC, well, at the first we need to know that the opposite side of the angle A is BC, and the adjacent side of the angle A is AB. But the longest side, AC, which opposite to the right angle, is called the hypotenuse. So we can say that the hypotenuse is the longest side in the right angle triangle, which opposite to the right angle B. And the first trigonometrical ratio, or the first trigonometrical function, is called sine. And we need to find sine of the angle A according to the angle A. Sine of the angle equals the ratio between the opposite side of this angle over the hypotenuse. The ratio between the opposite side of this angle and the hypotenuse. And the opposite side of the angle A is BC, and the hypotenuse is AC. So it's going to be BC over AC. Sine A equals BC over AC. And the second trigonometrical function is called cosine. To find cosine A, we need to find the ratio between the adjacent side of the angle A and the hypotenuse. And the adjacent side of the angle A is AB. And the hypotenuse is AC, so it's going to be AB over AC. And the third trigonometrical function is called tan. If we need to find tan A, we need to find the ratio between the opposite side of the angle A and the adjacent side of the angle A. And the opposite to the angle A is BC, and the adjacent is AB, so it's going to be BC over AC. Now we need to find the trigonometrical ratios according to the angle C. But at the first, we need to know that the opposite side of the angle C is AB, and the adjacent side of the angle C is BC, and the hypotenuse is AC. And the first function is sine. Sine C equals the ratio between the opposite side of the angle C and the hypotenuse. And the opposite side of the angle C is AB. And the hypotenuse is AC. That means it's going to be AB over AC. Sine C equals AB over AC. What about cosine C? As we said before, cosine of the angle equals the ratio between the adjacent side of this angle and the hypotenuse. And the adjacent side of the angle C is BC, and the hypotenuse is AC, so it's going to be BC over AC. And the third trigonometrical function, tan, if we need to find tan C, it's going to be the ratio between the opposite side of the angle C and the adjacent side of the angle C. And the opposite side of the angle C is AB, and the adjacent side of the angle C is BC, so it's going to be the ratio between AB over BC. AB over BC is the trigonometrical ratio of tan C. In the opposite figure, CAB is right angle triangle, or ABC is right angle triangle at A, where AB equals 6 centimeter and AC equals 8 centimeter. We need to find each of the trigonometrical ratios according to the angle B and angle C, and then prove that sine B cosine C plus cosine B sine C equals 1. What should I do? At the first, we need to find the missing side in the right angle triangle, BC, which represents the hypotenuse of the right angle triangle. And by using the Pythagoras theorem, we can find the missing side BC. It's going to be, since measure of angle A equals 90 degrees, that means this triangle is a right angle triangle. Then BC equals square root 6 square plus 8 square equals 10 centimeter. So now the length of the hypotenuse is BC, of the hypotenuse BC is 10 centimeter. And we find it by using the Pythagoras theorem. Now we can find the trigonometrical ratios according to the angle B. And the first trigonometrical function is called sine. And as we said before, sine of the angle equals the ratio between the opposite side of this angle over the hypotenuse. And the opposite side of the angle B is 8 centimeter. And the hypotenuse is 10 centimeter. So it's going to be 8 over 10. We can put 8 over 10 in the simplest form if we divide each side or each term of this ratio by 2. 8 divided 2 equals 4, and 10 divided 2 equals 5. And the second trigonometrical function is called cosine B. And cosine B equals the ratio between the adjacent side of this angle and the hypotenuse. And the adjacent side of the angle B is 6, and the hypotenuse is 10, so it's going to be 6 over 10. 6 over 10 can be written in the simplest form, 3 over 5, if we divide each term of the ratio by 2. And the third trigonometrical function is called tan B, and it's equivalent to the ratio between the opposite side of this angle and the adjacent side of this angle. And the opposite side of the angle B is 8 centimeter, and the adjacent side of the angle B equals 6 centimeter. So the ratio, or the trigonometrical ratio, is going to be 8 over 6. And 8 over 6 can be written in the simplest form, 4 over 3, if we divide by 2 up and down. Also, we can find the trigonometrical ratios according to the angle C. The first trigonometrical ratio is sine C. Sine C equals the ratio between the opposite side of the angle C and the hypotenuse. And the opposite side of the angle C is AB equals 6 centimeter, and the hypotenuse equals 10 centimeter. So it's going to be 6 over 10. And 6 over 10 can be written in the simplest form, 3 over 5, if we divide by 2 up and down. And the second trigonometrical function, cosine C, equals the ratio between the adjacent side of the angle C and the hypotenuse. And the adjacent side of the angle C is 8 centimeter, and the hypotenuse is 10 centimeter, so it's going to be 8 over 10. And 8 over 10 can be written in the simplest form, 4 over 5, if we divide by 2 up and down. And the third trigonometrical function is called tan. Tan C equals the ratio between the opposite side of the angle C and the adjacent side of the angle C. And the opposite side of the angle C equals 6 centimeter, and the adjacent side of the angle C equals 8 centimeter. So it's going to be 6 over 8. The opposite side of the angle C, 6 centimeter, and the adjacent 8 centimeter. So the trigonometrical ratio is 6 over 8, and 6 over 8 can be written in the simplest form, 3 over 4, if we divide by 2 up and down. Number 2, we need to prove that sine B cosine C plus cosine B sine C equals 1. The left-hand side, sine B cosine C plus cosine B sine C. We know that sine B equals 4 over 5, and cosine C equals 4 over 5. So it's going to be 4 over 5 times 4 over 5. And cosine B equals 3 over 5, and sine C also 3 over 5. So it's going to be 3 over 5 times 3 over 5. 4 over 5 times 4 over 5 equals 16 over 25. And 3 over 5 times 3 over 5 equals 9 over 25. Now we have two fractions having the same denominator. We can put the same denominator and add the two numerators. It's going to be 25 over 25. And we know that 25 over 25 equals 1, and this is equivalent to the right-hand side. From the previous example, we can deduce that if the two angles are complementary, or their sum equals 90 degrees, we can deduce that sine of the first angle equals cosine of the second angle, or sine of the second angle equal cosine of the first angle. We can deduce that from here. Sine of B is equivalent to cosine of C. Sine of B is 4 over 5. Also, cosine of C equals 4 over 5. And also, cosine B is equivalent to sine C. Cosine B 3 over 5, and also sine C equals 3 over 5. Number 2, tan B is equivalent to the ratio between sine B and cosine B. If we divide sine B by cosine B, it's going to be 4 over 5 sine B, and cosine B 3 over 5. So it's going to be 4 over 5 divided 3 over 5. We can keep the first fraction 4 over 5 and change the operation, divide it to multiplication sign, multiply, and then get the reciprocal of the second fraction 3 over 5. It's going to be 5 over 3. We can divide by 5 up and down. It's going to be 1 and 1. So the final result is going to be 4 over 3. And 4 over 3 is equivalent to tan B. So is equivalent to tan B. Again, now we deduce that the ratio between the sine of the angle B and cosine of the angle B is equivalent to tan B, because each one of them is equivalent to 4 over 3. Also here, tan C is equivalent to the ratio between sine C over cosine C. If we divide sine C by cosine C, it's going to be 3 over 5 by 4 over 5. We can keep the first fraction 3 over 5 and then change the operation sign, divide into multiplication sign, multiply, and then get the reciprocal of the second fraction 4 over 5. It's going to be 5 over 4. We can divide by 5 up and down. It's going to be here 1 and 1. And the final result is going to be 3 over 5, 3 over 4. And 3 over 4 is equivalent to tan of the angle C. Complete. If sine of the angle A equals 0.2 and cosine of the angle A equals 2 over 5, and we need to find tangent of the angle A, what am I supposed to do? We know that we can convert the decimal number 0.2 into fraction. It's going to be 2 over 10. And also 2 over 10 can be written in the simplest form, 1 over 5, if we divide by 2 up and down. We know from the previous that tan of the angle A is equivalent to sine of the angle A and divided by cosine of the angle A. And sine of the angle A is 1 over 5 divided by cosine of the angle A, 2 over 5. We can keep the first fraction 1 over 5 and then change the divide sign into multiplication sign and then get the reciprocal of the second fraction. 2 over 5 equivalent, its reciprocal is 5 over 2. We can divide by 5 up and down. It's going to be 1 and 1, and the final result is going to be 1 over 2. So tan of the angle A equals 1 over 2. Here, tan of the angle A equals 5 over 12. And cosine of the angle A equals 12 over 13. And we need to find sine of the angle. As we know that tangent of the angle A equals the ratio between sine of the angle A and cosine of the angle A. That means we can deduce that sine of the angle A is going to be the product of tangent of the angle A and cosine of the angle A. Tangent of the angle A is 5 over 12 and cosine of the angle A is 12 over 13. We can divide by 12 up and down. It's going to be 1 and 1 here, and the final result is going to be 5 over 13. That means sine of the angle A equals 5 over 13. In the opposite figure, the triangle ABC is an isosceles triangle where AB equals AC equals 15 centimeter and BC equals 24 centimeter. And we need to prove that sine of the angle B plus sine of the angle C more than 1. And tangent of the angle B times tangent of the angle C less than 1. What should I do? At the first, we need to make a construction. We need to draw a height AD perpendicular to the base BC. And now we got a theorem from grade 8. Since we have AB equals AC and AD perpendicular to the base BC, we can deduce that AD can bisect of the vertex angle and also bisects the base. That means D is the midpoint of the base BC, or BD equals DC equals half of 24 equals 12 centimeter. And in the right angle triangle ADC, since AD is the missing side of the right angle triangle, we can find it by using the Pythagoras theorem. So since measure of angle ADC equals 90 degree, so AD equals square root of 15 square minus 12 square, and it's going to be 9 centimeter. Now we can easily find any trigonometrical ratio of any angle. If we need to find sine of the angle B, we know that it's going to be the ratio between the opposite side of the angle B and the hypotenuse. And the opposite side of the angle B here is 9 centimeter, and the hypotenuse is 15 centimeter. So sine B equals 9 over 15. And if we need to find sine of the angle C in the right angle triangle ADC, sine of the angle C equals the ratio between the opposite side of the angle C and the hypotenuse. And the opposite side of the angle C is also 9 centimeter, and the hypotenuse is 15 centimeter. So sine of the angle C equals 9 over 15. 9 over 15 can be written in the simplest form, 3 over 5. Now we have two fractions having the same denominator. We can add them if we put the same denominator and then add the two numerators. So it's going to be 6 over 5. That means the value of the expression sine B plus sine C is equivalent to 6 over 5. And 6 over 5 can be written in as a mixed number 1 and 1 over 5. And this is more than 1. This is the first required. Number 2, tan B times tan C. We know that the tangent of the angle B equals the ratio of the opposite side of the angle B and the adjacent side of the angle B. So in the right angle triangle ADB, the opposite side of the angle B is 9 centimeter and the adjacent side equals 12 centimeter. That means tan of the angle B equals 9 over 12. And tangent of the angle C equals the opposite side of the angle C and the adjacent side of the angle C. And the opposite side of the angle C is 9 centimeter and the adjacent is 12 centimeter. So it's going to be 9 over 12. 9 over 12 can be written in the simplest form, 3 over 4, if we divide by 3 up and down. Now we can multiply these fractions. 3 times 3 equals 9, and 4 times 4 equals 16. And 9 over 16 is proper fraction. That means it is less than 1. And this is the second required. Example. In the opposite figure, ABCD is quadrilateral, in which measure of angle A equals measure of angle BDC equals 90 degree. and AD parallel to BC. And AD equals 6 centimeter and AB equals 8 centimeter. And we need to find the length of the line segment DC or the side DC. What should I do? At the first, in the right angle triangle BAD. BAD is a missing side. Actually, it is the hypotenuse of the right angle triangle. And we can find it by using the Pythagoras theorem. So since measure of angle BAD equals 90 degree and BD is going to be square root of 8 power 2 plus 6 power 2 equals 10 centimeter. So now the hypotenuse BD of the right angle triangle BAD equals 10 centimeter. And since AD parallel to BC, that means measure of angle DBC equals measure of angle ADB because they are alternate angles. That means we can say that the tangent of the angle DBC equals the tangent of the angle ADB. So we know that the tangent of the angle equals the ratio between the opposite side of this angle and the adjacent side of this angle. And the opposite side of the angle DBC is DC, and we don't have its length. And the adjacent side of the angle DBC is 10 centimeter. And tangent of the angle ADB equals the ratio between the opposite side of this angle and the adjacent of this angle. And it's going to be 8 over 6. 8 over 6 can be written in the simplest form, 4 over 3. If we divide by 2 up and down, we can find the length of DC by get the cross multiplication. If we multiply 4 by 10 and then divide by 3. So DC is going to be 40 over 3, and it's going to be a mixed number 13 and third. We can convert the improper fraction. This improper fraction can be converted into the mixed number 13 and 1 over 3. Another example. Find the value of x if x is an acute angle. If sine of the angle 10 plus x equals cosine of the angle 70. And number B, cosine of twice x equals sine of x. What should I do? As we said before, since sine A equals cosine B or cosine A equals sine B, that means the sum of these angles equals 90 degrees because they are complementary angles. So since sine of the angle 10 plus x equals cosine of the angle 70, that means we can deduce that 10 plus x plus 70 equals 90 degrees. 10 plus 70 equals 80. We can move 80 to the other side with different sign or with negative sign. It's going to be 90 minus 80. So x is going to be 10. Now we can find the second required. Since cosine 2x equals sine x. Also, as we said before, if cosine of the angle equals sine of the other angle, that means their sum equals 90 degrees. So 2x plus x is going to be 90 degrees. Now we can add the like terms to x plus x equals 3x equals 90 degrees. And now we can divide each side of the equation by 3. So x is going to be 90 over 3. And then x is going to be 30. Thanks, guys. Now the time is over. I hope you study hard. Wassalamu alaikum wa rahmatullahi wa barakatuh.